I am Afolabi Saeed Omotunde, Director, Access Point Academy. Yet again is Access Point Academy video lecture series. And in our video series today, we shall unravel the concept that has to do with nuclear radiation. Now quickly, the nucleus of some atoms are unstable. So therefore, to become more stable, these nuclei give out radiation. Now nuclei is actually the plural of nucleus. Okay, so this process is called radioactive decay. That is the process by which the nuclei of some atoms gives out radiation is what is meant by radioactive decay. Now, next, the question is what is radioactivity? Now, radioactivity is the spontaneous disintegration of an unstable nucleus. Okay, spontaneous, natural splitting of an unstable nucleus. That is what is meant by radioactivity. So, what are unstable nuclei? Now, unstable nuclei, they are the nuclei that can disintegrate on their own. They are the nuclei that will decompose on their own. Okay, emitting different kinds of radiation. So now, what actually makes a nucleus to be unstable? Now, a nucleus will be unstable if the ratio of proton to neutron, that is in the nucleus of an atom, if the ratio of proton to neutron is actually more than 1, if it is greater than 1, then the nucleus will be unstable. But if the ratio of proton to neutron are equal or just equal to 1, then that nucleus is a stable one. Now, let's look at an example of a stable nucleus. For instance, calcium has a proton number or atomic number of 20 and a mass of 30. Now, calcium has proton number which is 20 and neutron number which is also 20. So now the ratio of proton to neutron here is 1. So therefore, calcium is a stable atom. It has a stable nucleus, so it can never be disintegrated spontaneously. So now, example of those atoms that are that have nucleus that are not stable. So we have uranium, okay, polonium, radium, radon, thorium, and so on. So these are examples of those atoms that have nucleus that are not stable. So they are radioactive atoms. They can undergo the concept of nuclear radiation. Now, which scientists contributed to the concept of radiation? So we have notable scientists that actually contributed to the concept of radiation. We have the French scientist called Henri Becquerel. We have the Maria Curie. We have Pierre Curie. This is wife to this man. This man is the husband of this woman, Maria and Pierre Curie. Okay, they actually contributed to the concept of nuclear radiation. And also, we also have Lord Ernest Rutherford. Okay, also contributed. But this man, Henri Becquerel, from France, actually was the one that discovered the concept of radioactivity. Now, next is types of radiation. What are the types of radiation that are actually going to be emitted when an unstable nucleus disintegrates? So there are 3 types of radiations. So the first one is the alpha radiation that has the symbol. We have the beta radiation or beta particle that has that symbol, and we have the gamma radiation or gamma ray, gamma particle that has that. Now, very, very essential, we need to understand the properties of each and every of the radiations that we have. We need to understand their properties. So as a student of science, it is very, very essential you understand the concept and the properties. So the first one we're going to look at is the property of alpha radiation. So now, nature, how does alpha radiation or alpha particle look like naturally? So it has a value of helium nucleus. Okay, it appears to be helium nucleus as it is. So the subscript, which is 2, the superscript, which is 4, which means it has 4 mass, and 2 proton number or atomic number. Now the mass has a mass of 4 units, which is 4 mole. That is atomic mass units. Okay, then the charge. So alpha radiations are positively charged, so it has a charge of +2. Then the penetrating power, so it has a low penetrating power of the 3 types of radiation, so which means that the alpha particle has the least penetrating power rather. It has the lowest penetration power of the 3 types of radiation. Then ionizing power, so it also causes ionization in gases, so it has the highest ionizing power, so its ionizing power is high. Okay, now what happens to it in electric and magnetic field? Now in a magnetic field, it is slightly deflected by magnetic and electric field. So when you place alpha particles in a magnetic field, it's going to be deflected. When you place it in electric field, it's also going to be deflected. Now how about its speed? So it has a very low speed, so about 10% the speed of light. The speed of light is 3 multiplied by 10 raised to the power of 8 meters per second. So 10% of that value gives the speed of alpha particles, so 10% of the speed of light. Then absorber, so alpha particles can be stopped by a sheet of paper. A sheet of paper will actually stop alpha particle. So I'm going to show you the diagram of how we describe how the sheet of paper will stop alpha particle. Now next is the properties of beta radiation. Now nature, for beta radiation, they are fast moving electrons. Okay, they are fast moving electron, and as you can see the symbol, it has a proton number of -1 and a mass of 0. Okay, what's their mass? So they have negligible mass of about 1/2000 units, a very negligible mass. Then the charge, they have a charge of -1, as you can see from their nature. Okay, the magnetic and electric field. So what happened to them when we place beta particles in magnetic field and also electric field? So what's going to happen? Beta particles are deflected toward the positive plate in electric field and toward the north pole in magnetic field. Okay, so it's actually going to be deflected toward the positive plate in electric field. Why? Because its charge is positive. Its charge is negative and the positive plate is positive, so it's going to deflect it toward it and also toward the north pole in a magnet. Now what happened to its penetration power? Okay, so their penetrating power is higher than those of alpha particles, but lower than those of gamma particle. So which means that it can actually penetrate much more than the alpha particles, okay, but less than the gamma particles. So now what happens to the ionizing power? They also cause ionization in gases as well, but meanwhile the ionizing power is lower than the alpha particle. Don't forget we said alpha particles has the highest ionizing power, but higher than those of gamma ray. So what is their speed? So beta radiation have high speed of about 90% the speed of light. Don't forget we said speed of light is 3 multiplied by 10 to the power of 8 meters per second. So 90% of that will give us the speed of beta particles. So beta radiation are more faster compared to alpha radiation. Then what happens to their absorption? So they can easily be stopped by aluminum foils. So those are the properties we need to learn about beta radiation. Now the third radiation that is emitted from an unstable nuclei is the gamma rays, so of which we need to know their properties as well. So now the nature, they are electromagnetic radiation, so you have to know that they aren't particles, they are electromagnetic rays, they are electromagnetic radiations. So now mass, so gamma ray has no mass. Charge, they have no charge, they have no mass, they have no charge. They are generally represented as just, that is how they are. actually represented. That is gamma ray. That's your symbol. Now, what happened to them in magnetic and electric field? So gamma ray are not deflected in any context in electric field and magnetic field. So they just pass on directly, straightforward, like any other electromagnetic radiation. So they are undeflected by electric and magnetic field. So what's their penetration power? They have the highest penetration power of the three types of radiation. Then their ionizing power, so they have the least ionizing power. Then speed, they have exactly the speed of light, which is 10 to the power 3 multiplied by 10 to the power of 8. Okay, so kindly disregard this 8 written beside it 10. It is to the power of 8. Okay, so now absorber, so they cannot be stopped by sheet of paper or aluminum foil, but rather can be stopped by lead block. Okay, so now let's here we have the summary of the absorption property of the three types of radiation. Now, as you can see, this is alpha with the blue ink, this is beta with the red ink, and the purple one is the gamma ray. Now, this is a sheet of paper. So this is actually stopped. The alpha particle is actually stopped by the sheet of paper. You can see here. Okay, why the beta and gamma will pass through conveniently. They will pass through the sheet of paper. Now, when they encounter another obstruction rather, which is the aluminum foil. So now the aluminum foil actually stops the beta particles, but meanwhile it does not stop the gamma rays. So the gamma ray continue their motion, and when it encounters the lead block, so the lead block actually stopped the gamma ray, which is the which has the highest penetration power. So now those are the absorbing property, and like the speed of each of them, you can actually know it from that. Now, instrument, what instrument do we use to detect radiation? We have three important instruments that are used to detect radiation. We have the Geiger-Müller tube, which is also known as the GM counter. We have the scintillation counter and the diffusion cloud chamber. So now those are the instruments we use in detecting radiation. So now this course I'm going to stop here. So this is the first part of the course. This is the first part of the course. So now the second part is going to introduce to you in our subsequent video. Now try to subscribe to our YouTube channel, check us on Facebook, then our WhatsApp number is there. So thank you very much and have a blissful day.